So this talk is not the same thing that's on the outside. This is what it was, but people wouldn't figure out it was ops related, I think. So we added DevOps to the title, like all the things now are DevOpsian. So, but this really doesn't have much to do with DevOps in particular. Just wanted to warn you about that. So I'll talk a little bit about me. My name is Matt Rogish. I am the founder and CEO of a company called Reactive Ops. We do DevOps consulting and managed cloud stuff for our clients. Tens of millions of dollars of AWS and Google Cloud spend, and we also do pager for them with a 12-person company, so we need to be very good at disaster recovery and incident response. Up until recently, I was on pager too. Formerly a CTO of a Ruby on Rails hosting company called Rails Machine, where we also had thousands of virtual machines run by a handful of people, including pager. So we had to get also not terrible at the dreaded 2 a.m. wake-up calls. So if I say I've been woken up at 2 a.m. a lot, I hope that you will believe me. This is the flight simulator room at Delta Airlines. I went down there a couple of years ago and I toured their tech ops facilities and other things. And this is me landing a 757 at LaGuardia. And you can see the runway off in the distance. I landed successfully, but I forgot to put on the brakes, so I ran into the terminal building. It turns out you need to stop an airplane. But I've been an av geek for a long time, as many ops people tend to be. I don't know why this is. Like, there's a lot of talks relating to aviation and ops because there's something fascinating about air travel, in particular the machines. This is at Delta's Tech Ops facility where they actually all airlines have, or airplanes essentially last forever. They rip the things down on a schedule and they replace virtually every part in the airplane. So they don't really get old in as much as they just become uneconomical to fly. But this is a jet engine that they have, and there's another one in another bay. They're servicing jet engines from all sorts of different airlines. But if you look at it, and it's kind of small, but it's like a dystopic steampunk nightmare of wires and tubes and gaskets and spinning blades. And it's quite amazing that these stupid things can fly at all, but they do. And in virtual perfect safety, which is pretty astonishing to me. So as I said, I call this your airplane. How lessons learned from air disaster analysis can help you in an operations emergency or a critical incident. It's actually the safest time in recorded human history, except before the Wright brothers flew, as far as flying is concerned. It has been over 15 years since the last major airline crash, and that was in November of 2001. An American Airlines flight left JFK for Puerto Rico and crashed, killing all 260 people. But since then, there have been no U.S. major airline crashes. There have been a handful of smaller regional crashes. I think the last one was in 2006, Colgan Air. But since 2001, there have been over 15 billion passengers who have flown without incident just in the United States on a U.S. major airline. So it is the safest time in recorded history. Here's a graph that sort of shows that. Whole loss accidents per year have gone down dramatically. Although the millions of flights per year have gone up, the whole loss rate has gone significantly down. And these are fatalities per year since they were more or less recorded in 1940 up until 2011. So you can see a oddly U-shaped graph where it spikes around the early 1970s and has gone down since. And the reason why is in 1967, Congress created the Department of Transportation, which also created the National Transportation Safety Board, NTSB. And in 1974, the NTSB spun off as an independent agency. In the congressional act that made that happen, they said, no federal agency can properly perform such investigatory functions unless it is totally separate and independent from any other agency of the United States. And when we talk about things like blameless postmortems and other things, that separation is going to be kind of important. So as I said, the NTSB was formed officially in 1967 as a fully independent, a few years later it became fully independent. Whenever there's an aviation, train, bus, et cetera accident, they don't do just airplane crashes, although that's what they're famous for, National Transportation Safety Board. So any kind of regulated transportation accident, they form what's called a go team. They get on a plane, generally from DC, and they fly to wherever it is that the investigation needs to be performed. They participate in what's called a party system, where they bring in the FAA or the Department of Transportation, the airline manufacturers, Boeing, Airbus, whomever, the airlines themselves, in order to figure out what has happened, and then they present a factual report called their AAR, or the Aviation Accident Report. And their charter is an interesting one. It has the phrase, to ensure that accidents, or a particular accident, never happens again. And it's not to make them less, or to figure out what happened. It's to make them go down to zero, which is interesting when you think about, we'll talk about later, pager incidents and other things. A zero tolerance policy is sort of the right way to start thinking about this kind of stuff. So let's talk a little bit about United Airlines Flight 173. On a late December afternoon in 1978, UA 173 was traveling from JFK to Portland. As commonly happens in landing, they pulled the lever to put down the landing gear. They heard a big thump. The plane started shaking, and they were not sure if the main landing gear had actually come down successfully, because the green light that was supposed to light up didn't. So they aborted the approach, and they started circling around trying to figure out if, in fact, the landing gear had come down. And for about an hour, they did this, circling around in lazy circles over trees, over houses, whatever. And unfortunately for them, all of a sudden the first officer says, "We just lost 2 engines, guys." And the captain's like, "What?" "We just lost 2 engines, 1 and 2. They're all going. And we can't make Troutdale," which was an airport they were trying to land at. "We can't make anything." Captain says, "Okay, declare a mayday." Portland Tower, United 173 Heavy, mayday, mayday, mayday. The engines are flaming out, we're going down, we're not going to be able to make the airport. United 1, and that's the last transmission from the tower. The plane crashed a few seconds later, and the cockpit voice recorder ended as well. They were fortunately supremely lucky. Out of 180 passengers, only 10 died. But this was a completely preventable accident. What happened? They ran out of gas, because no one was paying attention as they were spinning around. As a matter of fact, they didn't know this at the time, but the plane was perfectly fine. The landing gear, there was a broken solenoid and actuator which gently lowers the landing gear. That broke, and so the landing gear landed with such force that it broke the switch, which told the airplane in the cockpit that the landing gear was successfully down. So they could have landed, no big deal. But the really terrible thing is that actually they did see this coming. The first officer is saying 15 minutes is gonna, really running low on fuel here. Nobody said anything. Number 2 is empty, referring to the number 2 tank. No one said anything. We got about 3 on the fuel, and that's it. 3,000 gallons of fuel, or pounds, 3,000 pounds of fuel. They measure, airplanes have so much fuel, they don't measure in gallons, they measure in weight. We're going to lose an engine. Why? We're losing an engine. Why? Fuel. They had seen this coming the whole time, but they were so preoccupied. And again, he also mentions it's not showing very much more fuel until finally, boy, that fuel sure went to hell all of a sudden. I told you we had 4, and now we've got 3. So they saw this coming the whole time, but no one in the cockpit was properly managing fuel. There was a breakdown in communications in the cockpit and what is now called crew resource management. So as a result of this accident, NASA and the NTSB jointly came up with this concept of CRM. And they studied human interactions and systems design relating to the whole process of how we train pilots, how companies, airlines manage things like this, and what do their checklists look like? Do they have checklists for such a thing? And it was designed to foster a less authoritarian cockpit culture. So the airlines came out of, perhaps unsurprisingly, the nautical theme, aircraft, watercraft, whatever. The captain of the boat in a ship was often the decider, right? This person was the ultimate person on the aircraft that decided whether or not they did a thing. Turns out that's really bad for crashes and for preventing accidents. You don't want that. You don't want a decider. You certainly need somebody who's an ultimate authority of the aircraft, but you need to foster a close working relationship with everybody on the cockpit so that you can avoid things like this. And you want to get rid of what's called power distance. And so if you look up power distance, you'll see a lot of interesting examples of airline crashes that have been a part of that, where the first officer or second officer, flight engineers don't exist anymore, but the flight engineer may pose something to somebody higher up in the hierarchy of like, hey, maybe we should think about this, or maybe we should not crash the plane. And the captain, preoccupied with, get there-itis or something else, ends up ignoring that person. And so a lot of procedures have come out of that explicitly state, if this person says X or Y, you can essentially take command of the aircraft. So there's actually a defined process for this. Submitted an attention getter. Hey, Captain, I think, state your concern. I think we might be running out of gas. State the problem as you see it. If we run out of gas, we will crash. State a solution. Maybe we should land. And then obtain agreement or buy-in. What do you think? And so this very simple 5-step process has demonstrably led to much fewer crashes. And when you think about your own companies, not only on the operation side of things, but like, how do you remove power distance in your organization? How do you remove power distance, and we'll talk about this a little bit later, in ops response? And then they instituted this concept of positive control. So what happens is when you want to take control of the airplane, you say, my airplane. And just like a SYNAC, I say, your airplane. And then, or if I hand it to you, I say, Tim, your airplane. What do you say? And I say, your airplane. Now I know I'm done, and it's your airplane. So it's always positive control. If you're working a disaster checklist, if your servers are down, something weird is going on, make it very clear when you have control or somebody else does. In our company, whenever we use the magical phrase, your airplane, when we indicate I am totally taking my hands off of a thing. And that has nothing, and it's not disaster response, but it's anything. This customer needs a response, your airplane. I know that now no one's waiting on me. I've given that person the ultimate responsibility in resolving this issue, your airplane. So if you can adopt mnemonics like that, or phrases or key things within your organization, you get muscle memory with respect to things like this, and you avoid two people trying to work the same problem at the same time, or you avoid confusion where somebody thought, why didn't you respond to that person? Well, I thought it was your airplane. Well, do you see in Slack where I told you it was your airplane and you said my airplane? So it avoids all those kinds of things. Let's talk about Air France Flight 447. This is a fascinating crash. It was a plane flight from Rio to Paris. On the evening of May 31st, 2009, this flight left Rio about 7:30 p.m. And around 1:35 p.m. disappeared from contact over the Atlantic Ocean. At night, over the Atlantic, when it's cloudy and snowing or sleeting, this is what you see. You see now just black. And this is actually an A330 cockpit, so this is what it would look like. I think you can even see people right there. That's what it looks like. So keep that in mind as we talk about things that have happened. We'll go back to this picture. Now we're going to dive in a little bit into how airplanes fly. This is called a pitot tube. And as you can see, it's a little bit discolored because of the extreme heat. These things are electrically heated, so they don't ice up. A pitot tube determines the airspeed or the air velocity over the wing of an aircraft, which is the only thing that's important. Sometimes you might wonder, why can't they use GPS to figure out, how fast a plane is going? Because the speed of an airplane over ground doesn't matter. The only thing that matters is the wind speed over the wing. And so they have an array of these little devices all over the bottom of the thing. Air comes in, hits a little diaphragm there, and it turns that into an electrical signal which tells you how fast the airplane is going. Well, the pressure and all that stuff. As you can see, there's a little bit of ice on here. This is bad. There should not be ice on this, because if you block that, the airplane no longer knows how fast it's going. And in an Airbus, Everything is controlled by computer. It's a fly-by-wire system. There's a certain amount of, they call them laws, primary and alternate law, that control behavior of the aircraft. It tries to keep you from crashing the plane. But when it doesn't know how fast it's going, it says, oops, your airplane. But most of the time, it's mine. So this particular airplane had a defective series of these in which they did not get hot enough to prevent ice blockage. Given that there's a whole array of them, it was not deemed a safety critical thing that had to be replaced right away. So the pitot tubes in this A330 were scheduled to be replaced in January of the next year. So at this point, they had not been. This here is a combination pitot tube and AOA, or angle of attack indicator. So as an airplane's flying, the angle of the wing that gets hit by the air is called the angle of attack. And you may have heard of Bernoulli's principle, where liquid or something flowing over a thing creates a low pressure zone. That's not how airplanes fly. I mean, it helps, but that's not really the main thing. Airplanes fly because air hits the wing really hard and pushes it up. Angle of incidence equals angle of refraction, F equals ma. And so as an airplane raises its angle of attack, eventually the angle of the wind hitting it loses its ability to keep the plane in the sky. So it's very important to know how fast you're going and what is your angle of attack in the airstream. And so this is an AOA sensor. These were fine in this aircraft. At 2:10 a.m., imagine you're in this dark airplane. The rumble of the wind is kind of gently lulling you to sleep as you're flying this airplane hours and hours. The captain had just entered crew rest a couple minutes ago, so he left the cockpit. There were 2 first officers in charge. At 2:10 p.m., the autopilot disconnected because the tubes were no longer providing accurate information. And that noise came through. That actually wasn't loud enough for me. Let's try that again. It's not too loud. Well, at any rate, at 2 in the morning, when you're half asleep, that wakes you up. Which means now the aircraft says, your airplane. The first officer who's the pilot in charge, in command, all of a sudden, taken by surprise, starts moving the stick around like this. Unbeknownst to him, when the airspeed sensors no longer are receiving data, the airplane, in addition to turning off autopilot, says, I'm going to remove the protections that are in place that are going to keep you from crashing this plane. He didn't notice that. So now the plane's going all over the place. And then
Stalled.
He hears that.
Stalled.
The angle of attack sensor registered over 30 degrees pitch, which is insanely, you can't do that. That is not how high you fly a plane. You lose laminar flow somewhere around there. And so in addition to not knowing what the hell is going on, he is now being told the plane is about to crash. Because a stall is when the airflow no longer can keep the plane up and you're about to fall like a stone. So he's freaking out a little bit. So Robert is the other pilot monitoring, not the guy flying the plane, says, we still have the engines. What the hell is happening? I don't understand what is happening. Bonin, or however you pronounce his name, is the pilot flying and says, damn it, I don't have control of the plane. I don't have control of the plane at all. And the plane at this point is perfectly fine. So we're in this darkened cockpit. He's sitting here, can't see him, and there's a little stick right there. He's doing this. The other guy is looking at all the instruments, trying to figure out why they're not reporting airspeed correctly and why the plane is flying all over the place. There was a little bit of turbulence, but nothing that would indicate that something was happening. So about a minute later, the captain re-enters the cockpit. The stall warnings unexpectedly had stopped, even though the plane was like this, because the computer, in a further fit of, I don't know what the hell's going on, had said, you are so far off the charts, I don't know what's happening, so I'm going to stop reporting a stall alarm. Turns out that when he stopped pulling back on the stick and it re-entered a normal zone, That alarm started happening again.
Stalled.
So pulling the plane back, which is what was crashing it, caused the alarm to stop. When he let go and the plane finally figured out, like, oh, okay, cool, you're back where I expect to be, the stall alarm went off again, indicating that he was crashing the plane. So he pulls right back on the stick, crashing the plane. The captain comes in, what the hell are you doing? We've lost control of the plane. We've totally lost control of the plane. We don't understand it all. We've tried everything.
Stalled.
All the while he's talking. This is going off in loop in the back as he's trying to understand what the hell is happening. Every time he lets go of the stick, it tells him he's crashing it. Every time he pulls back, it tells him he's not. So in Boeing airplanes, they have these two things here called a yoke. And they sit in between your legs, and they're actually mechanically linked. If you turn one, the other one turns. If you pull it back, the other one goes with you. They're physically connected in such a way that it's entirely obvious what's happening, what somebody's doing with the other one. And given the location and configuration of it, if Bonin was in an Airbus, he would be basically pulling the thing like this. The thing would be in his lap, jamming him to the seat, and his other pilot would have this jammed in his seat too. And so he would know, what the hell? Like why he would push back on the stick, on the yoke. Airbus, aircraft, do not do this. They have these two things over here called side sticks. This is in daylight. Remember I said when it was dark out you couldn't really see it. These are a fly-by-wire aircraft, much like a jet airplane. And the side sticks are not mechanically linked in any way. There is no feedback to the other pilot what you are doing, especially at night. Now, Airbus aircraft do have some warnings that happen when you do something like this. They would report side stick disagree. It would make a little message that would pop up somewhere on this like massive computers. Be side stick disagree, a little ping. While the computer is yelling at you, stall, stall, stall. This aircraft was not in that configuration. It was in what's called dual input mode, which is probably the stupidest configuration ever devised. Where what happens is if one person has the stick jammed way back and the other person has it moved forward a little bit, it's going to average those two inputs. Average, arithmetic mean. If you're pulling it all the way back and this person's pulling it down a couple of degrees, because that's all you want to like jam the plane into the thing, what is the net of that? Still way up in the sky. And since the pilot monitoring didn't explicitly call my airplane, he didn't make it clear that he was trying to not crash the plane. And so that is what would have sounded if the plane was in a different configuration. But that's not what it was in. So finally, after about a minute before they all die, as the plane is basically doing this at about 200 miles an hour, the pilot monitoring says, we need to climb. And Bonin says, but I've had the stick back the whole time. And the captain, unfortunately too late, is like, whoa, do not do that. Airplanes behave in a manner known as positive control. Basically, if you move the stick like this and let go, the airplane will naturally move back into a stable 1 or 2 degree up attitude. So all you had to do was let go, and the airplane would have kept flying. And so the captain says, no, don't climb, no. Descend then, give me the controls. Bonin finally yields the controls, and Robert finally puts the nose down. The plane begins to regain speed, but is still descending too fast. As they near 2,000 feet, the aircraft sensors detect they're about to crash.
Pull up.
So it tells them to do the thing that Bonin had been doing the whole time.
Pull up.
So what does he start doing? He starts pulling back on the stick.
Pull up.
Damn it, we're going to crash. This can't be happening. But what's happening? And the captain says 10 degrees
Pull
pitch,
up.
so they're still way too up. There's no time to build up speed, and the CVR stops recording 1.4 seconds later. So the aircraft fell out of the sky and impacted the water about 125 miles an hour, killing everybody. And this was another perfectly fine airplane. Nothing had happened to it. As a matter of fact, the pitot tubes, about a minute into it, regained, they de-iced and were totally fine. But because the airplane doesn't put itself back into normal law, it was still in this alternate law, they were able to fly it into the ocean. So we'll talk a little bit about First Air 6560. So this happened, the previous one happened in 2009. So even though there is CRM in a disaster, if you don't train, if you don't really make things explicit, you can still do it. I'm not going to talk about this one a lot. This happened in 2011 in August. And it crashed in Canada. It was a charter flight of 15 people on board and 12 were killed. I'm not going to talk about it too much other than it was another example of CRM gone awry, or where the first officer says things like, the first officer states the GPS is showing that they're off course. The first officer questions the captain as to whether or not they did something wrong. No response by the captain. The FO states the opinion that they should abandon the approach and then solve the navigational problem. 3 seconds later, the captain says no. And the first officer says, okay. Total breakdown in CRM. At that point, the first officer should have said, no, we're going to crash, like blah, 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 blah. So they were landing and basically missed the runway because they were off course. The first officer states, so let's just, ... and the captain interrupts him and says, continue the flight. First officer utters expletive. Pitch begins to increase. FO calls the captain by the first name and states, I don't like this. And then the ground proximity warning system says sink rate, which is something you do not want to hear when you're landing an airplane. And the FO states go for it. He then says go around. The captain calls for go around, and 0.6 of a second later, the plane crashes, killing both of them. Okay. I was like, is that mine? Oh. So that was just another example of it still happening today, although it's much, much more rare. It tends to happen less in commercial airlines and much more in private or charter airlines or things like that, because I don't know why that is. I mean, I think you could look at a whole bunch of reasons, but so just fly the major airlines and you'll be fine. So we've probably all seen this, right? Sort of switching gears rather dramatically from airplanes. This is the Oroville Dam in California, or at least this is the spillway, emergency spillway of the dam. And in March of this year, Lake Oroville filled up, which it had never happened before. So much so that water was spilling out over the top and over the sides and all sorts of other places. And so the people in charge said, oh, let's just use this emergency release valve that we've never tested before in the 60 years that this thing has been created. And so the very first time they used it, the thing totally exploded and broke because they never bothered to test it, ever. In the history of the thing, they literally built this thing in the 50s and then never touched it again. I'm surprised they could even work it. I don't know how they did it. So there's my first funny gif of the thing. As this is a talk about airplane disasters, it's really not a place to put it in there, so I brought the dam disaster in just so that I could put a Picard gif. So what does it have to do with ops or DevOps or whatever? Well, we can learn a lot in our companies from the concepts of CRM, NTSB incident response, and aircraft design, UX, to decrease the impact of production events or increase the survivability of system failures. So when we talk about the kinds of things we should be doing before an event, we should obviously design systems for reliability. A friend of mine is a Delta pilot, and that's one of the reasons why I was able to go down Delta and do all sorts of cool things. But I said, what are some of those secrets, right? Like those listicle things of 5 secrets that airline pilots won't tell you. So I said, tell me one of those listicle things. And he's like, actually, an airplane is always broken all the time. There's always something wrong with it. There's always some warning light that doesn't work. There's always some system that is not functioning correctly. However, everything is triply redundant, so it doesn't really matter. And I mean, it's not like we just put on our cowboy hat and say, yeehaw, let's go, right? There's a big thick book, MEL, that talks about minimum equipment list that says for any particular permutation and combination of out systems, whether or not you can fly that day. So just because a system is out may or may not mean that you don't fly that day. It depends on where you're going, what the meteorological conditions are, and a whole bunch of how many people are on the plane. So a broken system in one flight might be totally fine, and a broken one, another one might keep you on the ground. But it is all very methodical, very battle tested. So design your systems for reliability and understand what you can and cannot live with. Nobody wants to be paged at 2 in the morning when you have 100 nodes and one of them goes down. Your production system is not impacted by this. Have the concept of an MEL when you are designing systems for reliability to say, what is the minimum I need in order to keep this site alive? Then let me page. So if I've got 100 nodes and I need 90 of them to maintain a certain CLA, SLA, and maybe I page when like 90, when the first 8 go down and the velocity is increasing so that I get a little bit ahead of it. Something like that. Have defined checklists. We've all read the checklist manifesto. It came out a few years ago, but you should read it. It's fantastic. Have defined checklists for production outages, because at 2 in the morning when you've just been woken up and you're groggy, you're going to drop the production database because you forgot you were logged in to prod. Do a pre-mortem of events. It's kind of a fun thing to do. Do tabletop exercises, or say, what if the production database goes down? Is my site going to go down? I don't know. Maybe. Maybe not. Depends on how I've developed my application code. Develop a language for communicating. My airplane, your airplane. In commercial kitchens, when the chef tells you to do something, you use the word heard, indicating you fully understand and acknowledge what the chef just told you to do. There are no questions. Have something similar to say, like, I think I'm going to restart the database system. I hear that you're going to restart the database system. Wait, what database? Oh, shoot, I'm in prod. So have a well-defined communication system that allows you to pare it back and repeat along the lines of your airplane, my airplane. I intend to run drop table foo. I'm just in database mode today for some reason. And you intend to drop table foo on what server? Oh, on server 1, 2, 3, 4, 5. You intend to drop table 1, 2, 3, 4, 5 on server 1, 2, 3, 4, 5. Okay? Okay. Things like that. Conduct disaster recovery drills. That's in conjunction to pre-morteming events. What happens if you delete your production database, or Chaos Monkey for your infrastructure, just like Netflix does. And make visible the work. In a similar way to the Boeing versus Airbus yoke system, make it clear when somebody is in a system that somebody can pay attention to it and see what's going on. So if you are at 2 in the morning, have somebody else watching your screen. You can do a screencast while you're doing it so they can see, oh, you just typed production instead of staging or whatever. Make sure that when you're logged into production, maybe you make the background prompt red if you log into production systems. Make it say prod in big flashing letters. Make it say stage in big flashing, less flashing letters. That sort of thing. Make it clear what is happening so that you have a user experience environment that is more conducive to avoiding stuff. So as I mentioned before, change the command prompts on servers. These are just a few things before you fly. Agree upon communication and status processes, and have backups. So this is especially, we're a totally distributed company. So we say, all right, if production goes down, I get paged, I'm primary, you're secondary, we both get woken up. Don't have only one person get woken up. Have 2 people get woken up. We're going to then log into Slack. We're going to create a room called Incident Response 2, 3, 4, 5, or whatever it is. And then we're going to open up a Hangout. And then we're going to do that, and I'm going to screen share the whole time. You are going to handle communications, whatever that ends up being. And have backups. What if Slack is down? If half the internet's down, Slack's probably down too. What if Hangouts are down? Have Skype, have voice. Some series of things, because the first time that Slack is down while your site is down, all of a sudden you're like, I literally have no way to get in touch with the rest of my team. I don't have their phone numbers. I don't have them on Skype. I don't know how to get a hold of them. Have backups for those things and test them. Have prod-specific commands or permissions. So this is very, kind of tactically what could you do. I've seen in some people they remove or they alias or they change the name of RM to RM prod so that you can't accidentally paste in a command that says RM-RF database directory. You have to say RM prod. And you would be like, wait a second, I'm in production. Am I really wanting and intending to do that? And then can you pause PagerDuty? no one wants to be working a problem while their phone continues to alert every 30 seconds because like another system is failing, or like some alert system is continuing to remind you that the system is down. Find a way to disable PagerDuty for the extent of that, but put it on a timer so that it turns back on later. Because what will happen is you will turn it off, you will forget to turn it back on when you go to sleep at 3 a.m., the site will go down and everybody will stay asleep. So make sure you can only disable it for a period of time. You know, disable PagerDuty for an hour, something like that. So there are checklists for just about everything in an airplane. So when you lose an engine, the first thing you do is you take out your checklist and you go to the page in the checklist that says what happens when an engine goes out. And in all the checklists, the first thing they tell you to do is fly the airplane. For the same reason that we saw the United Airlines flight and the American Airlines flight, or sorry, Air France flight, is they forgot to fly the airplane. They forgot basic stick and rudder skills that would keep them from crashing while they were trying to work a problem. So hopefully your systems do not involve bodily harm. It's just an outage. No one's going to die, hopefully. Maybe you lose some money. Don't forget your basic incident response skills. Don't forget to fly the airplane. Otherwise you will make a mistake. So during an event, what's your black box, your CVR, which by the way are orange, because if they're black you can never see them. What's your cockpit voice recorder? What is your flight data recorder, which keeps track of all the things you're doing? If I'm logging into a production system, do a screencast of it while I'm doing this, so people will see what we did, that we can post-mortem it later. Have all of the commands that I type logged somewhere, so that somebody could reconstruct what I did and we can pinpoint what happened. In addition to all of the other logs that your running system are doing, centralized log management, authentication logging, all that stuff. One common refrain in the airlines and what we use, again, is it's only a mistake if we both make it. There's a reason why there are 2 people on the flight deck, is that it's only a mistake if both people make it. If the captain says, I'm going to crash the plane, the first officer says, no, everybody lives, provided the captain listens to the first officer. And so when you have somebody on pager who's doing incident response, do not have them be the only person that's awake when this is happening. Do not have them be the only person that's typing something when this is happening. Because they're going to make a mistake, and it's your fault as an organization that allowed that to happen. Because you didn't take basic procedures. Like I've seen incidents where people have dropped the database or whatever in production and they fired that poor person. It's not their fault. You set up a system that allowed them to drop the database in production. Should they be allowed to do that? I don't know, but you gave them that power. So you need to figure out whether or not you want to do that. Who's on the radios? Who's talking? The person that's flying the plane is often not the one who's doing the navigation. Pretty straightforward stuff. Somebody needs to look up, what this error message means. Maybe it's not the person who's also trying to do other stuff. Use intentional language, like my airplane, your airplane, I intend to do X, Y, Z. Orient from data. If you get an interesting error message back that you've never seen before, if you say, that's a data point that tells you something is going on, stop, take a breath, don't rush, figure out what's happening, and avoid task saturation. Turn off PagerDuty. On an airplane, and I don't have a picture of this, there's a button called Master Alarm, Master Caution. When everything's blowing up, you can press this button and silence the whole thing. Because you know the plane is having a problem. You don't need the plane to keep telling you it's having a problem. So find a way to avoid task saturation. If you are a manager or a boss or somebody, don't pester the person who's trying to figure out how to recover the database while they're doing it. Leave them alone. You talk to the person who's controlling the radios. Talk to them. What's going on? After an event, 5 whys are not enough. Infinite whys. Bob dropped the production database. Jane, deleted the user login. Whatever. Okay, well, sure. Should we allow them to do that? I don't know. Focus on the system. Look at the broader picture and say, should they be allowed to do that? I don't know. But just because something bad happened, don't scar as an organization. Bob dropped the production database. Okay. Should we get rid of prod access for everybody? Maybe. But don't do it just because one bad thing happened. Figure out how you can fix the system so that bad thing is not a bad thing. Either certainly reduce the production access, but somebody is going to drop the database at some point. How do you make dropping a database a non-event? Replication or whatever, I don't know. Review the playback. Talk with the engineer when you're going through that. What were you thinking here? When you saw that error message, what was running through your head? Why did you believe what you believed? Oh, interesting. Avoid survivorship bias. That's an interesting one. You're going to have a bunch of events that occur, and you're going to think that, these 3 things failed, and so therefore, let's keep focusing on these 3 things, but what about all of the other things that are happening and going on? Look back at the bigger system. And then do retrospectives, basic stuff. So now I'm going to talk a little bit briefly about GitLab. We all probably heard the problems that happened for them. Early in February, maybe it was the last day in January, they dropped their production database. A Ruby performance engineer attempts to create a new PostgreSQL replica for some performance testing. Runs into a bunch of trouble. Coincidentally, they get sort of some sort of spam DDoS sort of event that overwhelms the secondary database. It falls behind. The engineer attempts to restart replication by tweaking some parameters, gets some confusing behavior, and then decides to just destroy the whole database because he was sleepy and wanted to get their itis. And so then they lost their production database for a long time. Turns out there was a whole bunch, and this scrolls off the screen because there's way too many things that were wrong with their process. The database backups didn't exist. Oops. Snapshots were taken every 24 hours but actually couldn't be recovered from. And a whole bunch of other things. Basically nothing worked as part of their database backup routine. Why? I know a lot of things. There were a lot of things that happened. Somebody wrote a database backup script and then never tested it. So they created a database dump nightly database, like we all do, right? Like we've all written that, do we dump every night? Put it in there. In that directory in S3, there was literally not a single file. Meaning that engineer never came back the next day and looked to verify it worked at least once. You would hope to see at least one file in there that they had come back the next day and said, there it is, and then it'd fail again, and then okay, fine. There was literally no file in there. It had never backed up the database, ever, in 6 months or whatever it was. How did that happen? I don't know. Probably something in the organization caused that to happen. Maybe it was somebody who had never written a database backup before and didn't know to come check. I don't know. I'm not blaming them. But I'm saying as an organization, if you read the GitLab postmortem, that is not brought up. They did 5 whys. They determined that, why replication broke, but they didn't ask, why was that never tested? What is in our process, in our behavior as a company that allowed that to happen? Was there a checklist for this? No, because they're not a database company. That's why you should use RDS. Why weren't they using RDS? They're on Amazon. Amazon makes that pretty easy. I don't know. So that's what I mean when I say go to an infinite why thing and explore your organizational biases that say, why is it that we're even running our own Postgres? Why is a Ruby performance engineer trying to debug replication? Why isn't the DBA? Oh, we don't have any DBAs. Why don't we have DBAs? That was never discussed. That was an organizational assumption not to use RDS and not to have DBAs. I'm not saying you should have DBAs. I'm just saying there should have been a discussion in their 5 whys, in their retrospective, in their postmortem, where they said, sure, we're not going to, this is fine. This is a natural example of not having DBAs and not using RDS. Maybe. There was no mention of that. So I don't know. I don't know if they had any intentionality around why they didn't have any DBAs. So be intentional. Look at your systems. Fly the airplane. Thank you. We've got, how much time? 10, 15 minutes? Take some questions. Ended a little early. No questions? Seeing none, thank you for coming. Oh, wait, we have one in the back. Yeah.
Sure. I mean, in the aerospace industry, there's a lot of standards, right? A lot of documents, the FAA. Quick question with the mic. Sorry.
I was just curious if you have any insights. In aerospace industry, there's a lot of like well-documented standards, right? The FAA, Society of Automotive Engineers. In the commercial world, I see a lot less. We're all dealing with the same problems. You can make a reference to somebody dropping a prod database, everybody laughs. It's really not these industry standards outside of sort of military and aerospace world. And if there are, I'd love to hear some that, you know what I mean, like those standardized checklists and things like that, which are readily available in the aerospace industry. I don't see them in the commercial world, and I'm wondering why, and if somebody's starting them, who's got the best one started so far?
Sure. So, I mean, the simple answer is that, nobody dies when a database gets dropped, but plenty of people do if the wing falls off, right? So, like, there is a much higher degree of reliability necessary for safety-critical systems. So you need to have a broader process. I think the other thing is very much some concept of, not invented here, or, it's just a database, like, it's just a database. I know there's a PG dump command and I can run that. And it is trivially easy to destroy these systems. It is a little bit harder to not. And I think it's just a matter of, electricity finds its way through the least resistance. And least resistance is not doing that. I think that's all there is to it, is that it's so easy to destroy these systems, and it is somewhat complicated and hard to build resilient systems. So for example, if you're writing a Rails app and you have a production, Postgres database, you could write all of your queries in such a way that if the database went away, your app would stay online. Maybe it would be non-functional, it would return dummy data. That could be done. But most people should, choose to have a 500 page that pops up because that's too hard, or they don't think about it. And so, culturally why that is cost, I think. Did you have a question up there? You have to.
I was just going to say, it's not a question as much as a comment.
Sure.
Yeah, there's a bunch of us here from healthcare IT, and you can kill someone dropping a database.
Sure. Yeah, and not to mention with HIPAA, you can go to jail if you do some bad things.
In Matthew Syed's Black Box Thinking, he does a comparison of the postmortems in the airline disasters versus the healthcare industry. And it's a very interesting object study about one of the key things that makes the air disaster outcomes as far as improving that great graph you showed where the number of deaths per number of flights goes down is because fundamentally NTSB and a lot of other agencies that are based on it around the world adopted essentially a no blame approach. That all the data is transparent and shared with everybody across the planet in every country, all the things that were learned, and that while some airlines might or equipment manufacturers might lose money if they prove it was a mistake that needs to all get retrofitted, by and large, the entire approach to those retrospectives is one of everybody adopts it and all the data is shared openly. And then he contrasts that with the healthcare industry, where there's basically Byzantine secrecy and concerns about blame is sort of the primary response, and says that the number of medical mistakes per procedure has not gone down for 100 years. And he attributes that in that book to the importance of learning the lessons in an open and shared way, so that you can do the things you're describing here and everybody can learn from those lessons in a combined way. That blame is the correction killer. So it's very important not only to do the right things, but make sure that people don't get fired for that one episode. Otherwise, they're not going to tell you that they dropped the database.
Yep. Or they're not going to be truthful in why they did a thing. They're not going to explain their rationale. If you assume that somebody had bad intentions or were stupid or whatever, then you're going to make assumptions that are most likely wrong and miss the point. NASA actually has a anonymous, again, it's further removed from the airlines, where a pilot or anybody in the airline system can report something they're concerned about. It goes to NASA for the CRMU sort of concept. It's not even the NTSB. It goes to a whole separate agency where you can say as a pilot or as a flight attendant, I saw this thing that I think is wrong, right? Either a safety violation or any of those other kinds of things. And it's anonymously reported to NASA. They collect that, they share that with the airlines, they share that with the NTSB, and they figure it out. Who would, if you were a doctor at a hospital or you were a nurse and you saw a doctor, repeatedly making the same mistakes, where would you go? Your corporate board in your company, and then you have to deal with your corporate politics at your hospital system where they might fire you because of that, because that doctor's well connected with the director. So why don't we have that? That's super easy to set up. No one's ever done it. And again, with HIPAA, you lose 5 records, you could go to jail. I mean, it's highly unlikely, but you could. And so I have a feeling yes, on the one hand, it is important that we keep these, we keep some of these things there, but at the other hand, it is diametrically opposed to, proper notification. If you lose a laptop and you don't think anybody's going to find it, are you going to tell somebody? Maybe not, because you could maybe even go to jail because you lost that laptop. Probably not. But you're going to weigh. If there's a punishment attached to it, you're going to weigh whether or not you tell somebody. If you think the likelihood is that somebody's going to find that laptop and extract that data is relatively low, you're not going to tell anyone. And nothing is going to get fixed. Any other questions? Cool. Thank you. Fly safe.